Okay, this is video 1 from Unit 9, Lesson 2. So we're still talking about the same learning target. In this lesson, though, we're going to look at adding and subtracting. Okay. So when you simplify sums and differences, you want to combine these like you would do like terms. So you combine like radicals the same way you combine like terms with variables. So 2 and 2 square root of 2 are like radicals because they have the same number underneath. 4 square root of 7 and negative 12 square root of 7 are like radicals. These are unlike radicals, square root of 5 and 3 square root of 6. Those are not the same. And then 4 square root of 11 and 2 square root of 10 are not the same either. Okay, so we basically do this the same way we combine like terms. Okay, so just like with like terms, if this were x plus 3x, so instead of the square root of 2, let's just look at it like it's an x. X plus 3x, so there would be a 1 in front of that x. X plus 3x would be 4x. So same thing here. There's a 1 in front of this square root of 2. So 1 square root of 2 plus 3 square root of 2 is 4 square root of 2. Just like with variables, whatever's the like term, so like up here was x, it stayed x. Here it's square root of 2, so it stays square root of 2. So I don't do 2 plus 2 and have 4 square root of 4. The square root of 2 stays the same. Okay, this one we're subtracting, but again, we still do it the same way. So negative 3 minus 4 is negative 7, and then square root of 5. Okay? 1 square root of 10 minus 5 square root of 10, that's going to be negative 4 and square root of 10. Okay. Good. So let's look at this note here. If they are not like radicals, so if they're not like radicals to begin with, check to see if any of the radicals can be simplified. So sometimes we have to simplify before we can add or subtract. So 7 square root of 3 minus square root of 12. These are not like radicals right now because 3 and 12 are not the same number. However, 12 can be simplified. So I can simplify square root of 12 because 4 is a perfect square and it goes into 12. So I simplify it like this. Okay. So let me just bring this one down because there's nothing to be simplified there. Now I have like radicals. So 7 square root of 3 minus 2 square root of 3 would be 5 square root of 3. Okay, look at the next one. This would be a good one for you to do on your own, just to practice. Alright, the 3 square root of 3 cannot be simplified. There's not a perfect square that goes into 3. But 2 square root of 27, 27 can be simplified. Because 9, that's from my perfect square list, goes into it. And it's 9 times 3, which equals 27. My negative 2 times 3 times square root of 3. So that's negative 6 square root of 3. Remember, you can combine the negative 2 and the 3 when you're multiplying here. They're both outside. Okay? So I'll bring this 3 square root of 3 down. So 3 square root of 3 minus 6 square root of 3. So 3 minus 6 is negative 3. and my like radical stays the same. Okay, on number 6 here, I see that 20 and 5 are not like radicals, but maybe they are because 20 can be simplified. So I'm going to keep this 3 out front. 20 simplifies to 4 times 5. So I use 4 and 5, not 10 and 2. I use 4 and 5 because 4 is the number from my perfect square list. So I'm going to go ahead. That's 2 square root of 5, and then 3 times 2 is 6 square root of 5. Ooh. Okay, plus, I just bringing that down. 6 square root of 5 plus 2 square root of 5 is 8 square root of 5. Okay, so when we add and subtract radicals, we get practice simplifying as well. We're ready to do Unit 9, Assignment 3.